All right. Hello, all, and welcome back to Introverse Uncharted, the show that aims to remove the gravity from your world and send you on a journey throughout the stars. As always, my name is John, and I will be your guide into the Introverse today. Once again, guys, congratulations on making it to the halfway point of the week. I know the task at hand isn't always an easy one, but be proud of whatever you've accomplished this week, and if this week has been rough on you so far, a stiff drink may be in order. As always, as we start the show off, let's run through some of the standard housekeeping before we lift off for the galaxies and nebulas deep beyond our fingertips into the universe. Number one, if you're joining me here for the first time, this is an amateur podcast, so background noise is always possible and is highly likely. I've mentioned it in previous episodes, but again, I've a kid and dogs and people in and out and noise from outside, whatever. There will occasionally be something you hear in the background. I apologize in advance for that, but not a whole ton we can do about that. I'm sure in the future we will find devices to do so. Again, if this is the first time that you're finding me, or if you've listened to every episode that I've done so far, and you're wondering just where you can find more Introverse Uncharted content, well, I got the hookup for you, alright? So, over on TikTok, I've been doing a ton of TikToks, trying to kind of expand my my reach on that platform a little bit. TikTok, I'm at Introverse_Uncharted. Instagram, at Introverse_Uncharted13. And then Facebook is just Introverse Uncharted. Also, just here on YouTube, obviously you can see all the episodes we've done in the past. Looking to do some probably YouTube shorts here in the future. But if you haven't already, please go subscribe to the channel. Go ahead and hit the pause button right now. And go over there, hit the subscribe button. Let's get those subscribers up a little bit, and before we know it, I'll go do some lives or something like that, depending on the event. We have some cool stuff coming up in the future. And then over on TikTok as well, if you guys go over and subscribe to me on TikTok, once I hit the specific limit, I'll be able to do some lives over there as well, and hopefully expand a little bit on what we do over there. Like I said, guys, I hope you guys are having a good week. It's April 25th, 2023, and plenty has happened in the last couple of weeks or so. I did 2 episodes last week. One, just my regularly scheduled programming, and the other one, a breaking news episode, if you will, about Starship. So Wednesday's episode was just a absolute breakdown of what Starship is and what the mission was designed to be. And then the Thursday episode came post-launch, where I just kind of informed you guys of, what happened and how it looked, and here we are, almost a full week later, and really we still don't know a ton. Let's get into some of these pre-flight checks, if you will, before we hit ignition and head into what we're going to be talking about on today's episode. So our pre-flight checks for today are, let's hit Starship one time real fast, just to give you an update on what we know as of now. At least one hydraulic power unit was destroyed. I've pointed it out before, but you can kind of see it in the flight. The HPU is used for assisting the steering of the Raptor engines. As I said before, there is speculation that the HPUs could also assist in the stage separation. However, SpaceX still hasn't really commented a ton on what they know or what they've seen. Damage at stage 0 on the ground is a lot worse than I think people thought, or at least visually it's a lot worse. The tank farm, if you look at the tank farm, that is definitely dinged up. The tanks hold water, liquid oxygen, and liquid nitrogen, and one of the tanks had a puncture in the side of it that you could see some steam or some exhaust coming out of. So obviously that's bad, and they're probably going to have to replace that. But the rest of the tank farm looked okay, aside from just a little bit of warping, probably from the sheer velocity of the exhaust coming out of Starship. The launch pad is pretty messed up. There's a crater underneath it now. Concrete was thrown, into the ocean, down off the pad, a bunch of stuff. There's a lot of damage. I talked about NASA Spaceflight's van being hit by a giant chunk of concrete. Concrete definitely went everywhere, and now they're talking about adding a cooled water-cooled plate essentially underneath where the rocket will launch from, under the orbital launch mount, where once the exhaust hits it, it'll start trying to cool down and hopefully divert the flames. But they still have said they don't want to do a flame diverter unless absolutely necessary. And honestly, I think that this proves why it's absolutely necessary and why NASA did it with SLS and the shuttles and all that. So, yeah, I mean, probably something they'll talk about a little bit more in the future. The OLM, the orbital launch mount, was also dinged up. You can see a lot of the plating blown off, a lot of you can see scorch marks, all sorts of stuff like that. So I'm sure they're going to have to take a look at the OLM and see if that's going to be ready to go again. There was also speculation that the chopstick control unit was damaged. You could see like bullet holes in the side of it. They hadn't moved it up until Monday. So Monday they finally lowered the chopsticks. So hopefully they just waited so long so they could make sure that it was safe to do so. But that's really the rundown of what we know. SpaceX hasn't dropped a whole ton of information so far as to what happened during the flight. We can all just speculate. I've seen things like when liftoff was occurring, the exhaust threw concrete up into the Raptor engines, and that caused some of them to go out. I think there was 3 out before physical liftoff. And also that could be what made it kind of tilt and launch a little sideways. But again, no true information from the mouth of SpaceX. What's next though for SpaceX and for Starship? Elon has said that he thinks that they'll be ready to go again in 1 to 2 months, and that includes repair time. So I'm gonna go ahead and go out on a limb here and say that that's Elon time. That's not real life time. And from the damage we can see, kind of at level, at stage 0. I think it's going to take a little longer to be operational and ready to go. However, if you go, NASA Spaceflight has a 24-hour coverage of Starship base. If you go and look, they are already working on Ship 28. Ship 28 was moved yesterday into the hangar and lifted up. And today, right now, as we speak, there is somebody up on a crane, essentially, working on that unit. So who knows? Maybe Elon's putting some pep in the step, and they will be ready to go in 1 to 2 months. But between ground damage and trying to figure out what happened to the last vehicle, I think it'll take a little longer. I think I said it in the update episode, but I'd just be happy if Starship launches by Christmas, and we can just count that as a space-related Christmas present for all of us enthusiasts out there. On Tuesday, iSpace launched, or they didn't launch, they launched it 10 days prior, but the Hakuto R Mission 1 lunar lander finally made contact with the moon on Tuesday. It was a 10-day journey there through orbit of the Earth and then catching the gravitational pull of the moon. It had to go all the way around the backside of the moon before it got stationary at the front. As it came down towards the surface, it had to use exhaust to brake itself, to slow itself down, and then it was intended to make contact with the moon. I did watch this happen live, and they had a animated situational, like, this is what's happening right now kind of thing happening. They got to the 0 count on the countdown where it was supposed to hit the moon, and nobody celebrated. And once they started to try to reestablish communications with the module, they could not. So, at least as of right now, there has been no contact made with this vessel, and there's a chance that it is a complete loss. If for some reason the animation didn't add up to what was actually happening in the moment, there's a chance that instead of it being a lunar lander, it became a lunar barrier and just plunged onto the lunar surface at high rates of speed. That's assuming that the animation was not on track with what was actually happening in the moment. If the animation was correct and it did touch down completely fine, they just can't establish a communication with it. And if they can't establish a communication with it in the next handful of days, I would assume, well, that's a mission failed, and it's pretty dead in the water, which that would be disappointing. The lunar lander was intended to be used for a lot of different companies and a lot of different missions to the moon, kind of to determine conditions on the moon, what's happening in that area, all sorts of things testing the ground, using a bunch of different prototype equipment to, again, just test lunar surfacing. Artemis had signed on to use its technology too for the Artemis 3 landing mission. So it's going to be sad if that did lose communication and it's essentially a gigantic handful of millions of dollars lunar paperweight. But that's essentially what it would probably be until, the next mission to the moon goes, which to my knowledge would be 2024 for 2024 is just the orbital mission, so it'd be 2025 for the lunar landing mission, which that'd be 2 years worth of giant lunar paperweight, so that would be exceedingly sad, and hopefully that's not the case. But if it is the case, it'll sit there until Artemis arrives, essentially to either look at it or they'll just scrap it and call it a day. But hopefully that's not the case. Now that we've gone through our pre-flight checks, and seems that launch systems are a go, and we are going to be cleared for liftoff today.
12, 11, 10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
So today would be just about 3 days after the 33rd anniversary of the launch of the Hubble Space Telescope. So today we're gonna talk Hubble a little bit. We're gonna talk about what the Hubble Space Telescope is. We're gonna talk about some images that have been taken by the Hubble Space Telescope, and some of the scientific discoveries that Hubble has helped us uncover in its 33 years in space, which is incredible. Lots of longevity. So Hubble is named after the trailblazing astronomer Edwin Hubble. Edwin established the fields of extragalactic astronomy and observational cosmology. Sorry about that. He proved that objects previously that were thought to be just dust and gas that we classified as nebula, some of them were actually galaxies beyond the Milky Way. Hubble also provided evidence that recessional velocity of a galaxy increases with its distance from the Earth, which is a property now known as Hubble's law. And the Hubble law implies that the universe is essentially expanding, which if you listen into a lot of these guys talking now and read a lot of the books, again, I'm obviously a huge Neil deGrasse Tyson fan, it's obvious to us that the universe is expanding, and it's expanding rapidly. It's going faster and faster and faster the further you go. And the further you look out, it's kind of like looking back in time. You're seeing things younger than they are right now because of how long it takes for light, essentially, to reach us in our telescopes. The telescope itself, it's a large space-based observatory. It was launched into orbit via the Space Shuttle Discovery, April 24th of 1990. And that was serviced in between then and 2009 was its last servicing mission, SM-4, which was flown by Atlantis. Definitely scheduled to be its last servicing mission. But on that servicing mission, they replaced a data handling unit. They replaced a couple different systems. They installed improved nickel-hydrogen batteries, replaced a couple other components, including all 6 gyroscopes. SM-4 also installed 2 new observational instruments, a wide field camera and a soft capture and rendezvous system. The rendezvous system is essentially one of the things utilized whenever Hubble is retired and brought back to the surface of Earth. They did a couple missions in the early 60s where they launched similar smaller missions for observing deep space. Most of them failed within a year. One failed within 3 days, the OSO mission, and then the OAO mission lasted about 4 years. But in 1968, NASA started developing plans for a true space-based reflecting telescope with a 3-meter mirror about 9.8 feet in diameter, known previously as the Large Orbiting Telescope or Large Space Telescope, which would have been LST, with a launch slated to be in 1979. So obviously, there's a big gap in between when the plans said we were going to put it up there and when it actually got put up there. But these plans, the big thing is that it emphasized that we needed crewed maintenance missions to this telescope to ensure that such a costly program would also have a very lengthy working life. We didn't want this one to be brief. We wanted to put a bunch of money into this and be able to maintenance it and keep it going for, obviously, 30 plus years. And we also had just obviously developed the space shuttle technology, or were working on it. 1981 would have been STS-1. So we were working on the technology, and both of those would have kind of coincided at the same time, which is pretty cool. Telescopes have a particular range that they can detect. So Hubble's domain extends from ultraviolet through visible light, which is what we can see with our eyes, and then into near infrared, which is a whole different light spectrum that we can't make out. This range has allowed for Hubble to deliver stunning images of stars and galaxies and other astronomical objects that have inspired people around the world and changed our understanding of the universe and where we come from and how old the universe is and stuff like that. Hubble has made more than 1.5 million observations over the course of its whole lifetime, and over 19,000 peer-reviewed science papers have been published on the discoveries of the Hubble telescope. Every current astronomy textbook includes contributions of this observatory. The telescope has tracked interstellar objects. We watched a comet collide with Jupiter. It's discovered moons around Pluto, dusty disks and stellar nurseries throughout the Milky Way. Just plenty of awesome, very huge discoveries that we wouldn't have been able to find without this deep space telescope. Hubble has peered back into our universe's distant past to locations more than 13.4 billion light years from Earth, capturing galaxies merging, probing the supermassive black holes that lurk into their depths, and helping us better understand the history of our expanding universe. In its over 30 years, Hubble has made observations that have captured humanity's imaginations and deepened our knowledge of the cosmos. Hubble has transformed our understanding, clearly, of the universe, just based on how far back it can look. It has seen... it's explored dark matter, which we still don't know what dark matter is. Dark matter is a mystery to us. Some people now are calling it dark energy too, but it's still a mystery. It's not something that is proven. It's a theory, but it started to try to look into what possibly dark matter could be. It's answered a lot of compelling questions, especially about where we come from in the origins. But throughout history, humanity's eyes on the universe have never been seen with more clarity or focus than what Hubble has brought to us. And the best example, in my opinion, of how much Hubble has shown us will always lie in the Hubble Deep Field images. Now, for those of you who are space enthusiasts like myself, you'll know that James Webb Space Telescope just also did a deep field image, which essentially looked into the same exact spot that Hubble looked into and fired off a bunch of pictures. I think it's something like 18 different composite images. I'm actually way off. Okay, 342 separate exposures, and then it pieces them together side by side to establish what this picture looks like. And it uses blue and red and infrared light in order to see as much as we can possibly see and get more of a detailed image of what is going on. Now, if you look at the Hubble deep space image, the deep field, most of the galaxies in it are pretty faint, 4 billion times fainter than the human eye can see. But it had never been done before, except for by this level of telescopes. The deep in Hubble's deep field just refers to the ability to look at these far, faint objects. Even from our own sun, it takes 8 minutes and 20 seconds or so for light to reach Earth. So when we look at the sun, we're actually looking at what the sun looked like 8 minutes and 20 seconds ago. So the further away we gaze at an object, the younger it appears to Hubble. So the deep field was like a core sample of space showing different galaxies, and at the earlier and earlier stages of their development, the deeper that they appeared into the image. They took more than just one deep field image. So Hubble did an ultra deep field in 2004, which captured a million-second long exposure, and in that million-second long exposure, they found 10,000 galaxies. The image of the ultra deep field, observed the first galaxies to emerge from the Dark Ages, which would have been what was considered to be the time right after the Big Bang. A surveying mission in 2002 installed this advanced camera for surveys. The advanced camera had twice the field of view and a higher sensitivity than the original camera. So the final ultra deep field photo is actually a combine of a couple different images, but using this this new and advanced lens and a near infrared camera, essentially. The ultra deep field showed several odd galaxies, such as one shaped kind of like a toothpick and others shaped like a bracelet link. These galaxies come from a way more chaotic time when it would have been before the development of our own Milky Way, which looks super condensed and super pretty, right? But in that time, when there had obviously just been a gigantic, massive explosion of everything coming into existence, they were a little bit messier back then. They also did the Hubble Ultra Deep Field Infrared, which in 2009 they captured near infrared light wavelengths in the same region of the Ultra Deep Field, revealing galaxies just 600 million years after the Big Bang, which is super fast. 600 million years sounds like a lot, right? But in terms of how long the galaxy or the universe has existed, that's just a tiny pinprick on the calendar. The light from the specific object that they found traveled 13.2 billion light years to reach Earth. Just so long for us to be able to see that. And like I said, it shows you how long it takes for light to reach us from distances, including the sun, 8 minutes and 20 seconds. Hubble had an extreme deep field as well. In 2012, Hubble took it to the extreme with a combine of 10 years of photographs taken in order to create this one image. And the extreme deep field still showed 5,500 new galaxies. And then in 2012, they did one more. And after observations for about 6 weeks in August and September of 2012, a team of astronomers discovered several, I think the number is 7, primitive galaxies that formed right when the universe would have been 3% of its age. So the observations supported the idea that galaxies had provided enough energy to reheat the universe after the Big Bang. A lot of the images that I always think of, aside from Deep Field, because Deep Field just got re-brought to our attention, right, with James Webb. But outside of that, when you think about Hubble, like I always think about the nebulas that it has captured over the years. The Orion Nebula, NGC 1999, the Helix, the Crab, the Heart of the Lagoon, Necklace, Butterfly, Spire and the Eagle, the Pillars. The Pillars is an absolutely iconic image. The Pillars of Creation from Hubble is an iconic image of the Hubble Space Telescope. It's also taken pictures of hundreds of galaxies. Some of them with names that I can't even give you because they are super long numbers, essentially. But they have the Long-Armed Galaxy and the Galactic Portrait and Eye in the Sky and Rubin's Galaxy and stars forming spirals. They have one called the Spiral Galaxy with a peculiar arm, it just looks kind of like a lopsided spiral. But these images are iconic in space imagery. They are clear shots of such a distance away that we never would have seen them without this advancement in technology. And Hubble has brought them to us for years and years and years and still sends us images to this day. Even with as old as it has outlasted its expected usage, and I'm glad that it has, and I'm sure the scientific community is also glad that it has, so that we can continue to learn about the origins of our universe and other things that it has looked into, which is what we're going to get into now. Hubble has helped a ton. I said 19,000 scientific papers have been accredited to Hubble. Hubble has helped us narrow down the age and the expansion of our universe. Pre-Hubble, the universe was originally thought to be about between 10 to 20 billion years old. With Hubble, and how far we can look, and now James Webb is also going to do some deep work on this, but with Hubble we narrowed it down to about 13.6 billion years. It's done extensive looking for black holes. Black holes are at the center of most galaxies. There are some exceptions to the rule, but there is generally a supermassive black hole at the center of all galaxies, including our own galaxy, the Milky Way galaxy. There is a supermassive black hole in the center, which helps with the gravitational spiral that always continues to happen. It helped determine the mass and the size of our own Milky Way galaxy. In March 2019, observations from Hubble and the data from the European Space Agency's, I think it's called Gaia mission, GAIA, were combined to determine the exact mass of the Milky Way galaxy to approximately 1.5 trillion times the mass of the sun. So all of the stars and all of the planets and everything in it, the mass is estimated to be 1.5 trillion times the mass of the sun. And obviously to us, the sun looks absolutely massive. This just definitely, Hubble and James Webb just show us how small we are, if you're really thinking about it. Hubble was not the first telescope to be launched into space. However, through the eyes of the Hubble Space Telescope, we have learned about the origins of the universe and seen beautiful cosmic items invisible to the naked eye right up close and personal through that lens. Between the 30-plus years of service of Hubble and the recent launch of James Webb, our eyes on the universe are finally opened. We're not blind to what is outside of our backyard, our solar system, and honestly, even our Milky Way galaxy. Through these instruments, we will learn so much about the origin of our universe, where these awesome cosmic items come from, and how they are made, and whether or not there is other life in the cosmos. So let's kind of talk about a couple things, okay? So for me, I know I do this, but like when you look into the night sky and you think about the night sky itself in comparison to these images that came to us through the lens of Hubble and through the lens of James Webb, it makes you wonder what else is out there just waiting to be discovered, right? Because I've said it before in a couple of the other videos, but I mean, the deep field image that Hubble has taken that James Webb took, if you hold up a grain of sand to the sun, essentially, that's the amount of space that image covers. Okay, so it's not a lot of space. So just think about it, if you covered the entire sky with those images, that there is so much for us to discover out there. And what does that mean for the conversation of, is there life outside of the solar system? Outside of our backyard, outside of what it is that we know and some of us think about every day, but I'm sure not everybody does. But life outside of the solar system, extraterrestrial life, things deep into space. Obviously, I think I've said it before, I'll say it again, I'll say it until, I'll say it forever. It is absolutely ignorant of us, or of anybody, to think that life on Earth is it. That there's no other life anywhere else. The universe is full of hydrogen and oxygen and nitrogen and all sorts of these key elements for life. So, I know through the eyes of Hubble and James Webb and other various technologies, we've found other planets in Goldilocks zones near suns, essentially, giant stars kind of like our own. So there are the immense possibility that there is life out there. Like I think it's a certainty that there's life out there. We just have not discovered it yet and not seen it yet. And I'm sure that there are also those of us listening who would argue that maybe we have. That maybe they've been here. I've heard the pyramid argument and all sorts of stuff like that. Nothing says that these things are not possible. I'm not as much of a conspiracy theorist as a lot of others. But sure, maybe the possibility of extraterrestrials being here at some point or another has happened. But I think it would be weird to travel all the way across the galaxy and not say hi or destroy us for being lower life. Seriously, if they got to us from wherever it is they came from, they are far more advanced. So I'm sure that they could annihilate us if they really, really chose to. But what what also does this do for our reach just in the universe, okay? I talked about this in the Starship episode, but Starship is a vessel that is going to take humans physically beyond Earth's gravity to things close to us and hopefully eventually further from us, so we can learn more and more about what the universe has to offer. You know, their whole thing is, you know, to the moon, to Mars, and beyond. So beyond, in my opinion, is what Hubble and now James Webb do right now. They are our eyes beyond the reach of our sun's gravity to show us, if you will, the pillars of creation, the origin of this vast universe. And through these instruments, I think the depth of the knowledge that we can gain is endless. It's just up to us to break it down and to actually observe and to learn, because otherwise it's just useless and endless information, essentially. James Webb and Hubble, like I said, they have done absolutely beautiful things for us. The images that have come from these things is absolutely incredible. The nebulas, some of my favorites, the Butterfly Nebula, the Crab Nebula, the Heart of the Lagoon Nebula. Like, these are all exceedingly beautiful images of deep space and gas and dust and stars being created that we would not have seen without the advancement of these technologies and of these telescopes. If you get a second, seriously, check out the deep space image. Both of them. Oh, I can't even say both. There's like 10 of them. Hubble took like 10 of them, and the James Webb did take one. But the James Webb one especially is just an absolute sight. It's beautiful to see how many galaxies are in such a small space. Some of them combining, dancing around each other. This universe is obviously moderately endless. And I think there are so many great things that we have yet to discover. And with the technologies that we are currently working on, I think that we will be able to do so. Maybe not entirely in my lifetime, but I think the longer you go and the more you learn, we're going to figure out a lot about where it is that the universe came from, how we came to be, and whether or not there is life beyond just what we know here. And like I said, I think obviously there is. It's just about using what we have to discover it. All right, guys. So today we talked about the Hubble Space Telescope, what it is, what it takes pictures of, what we've learned from it. And honestly, like, that's still just a small sampling. There is lists and lists and lists of things that Hubble has taken pictures of and things that we have learned from Hubble. All sorts of the equipment on board of Hubble that I didn't get to. Hubble is full of different cameras and different technologies, which is, again, that's incredible. It's a bunch of different lenses for which we can see deeper and deeper and deeper into the universe. They have a cosmic origin spectrograph, advanced cameras for surveys, the Goddard high resolution spectrograph, high speed photometers, wide field planetary cameras. They have 3 of them. So it can see through plenty of different lenses into plenty of different ways of seeing the universe in forms of light that we just can't see. So I'm going to end, as always, with a quote of the day. Try to do that, like I said, every week. So the quote of the day this week is, "The future depends on what you do today," which is a quote by Gandhi. And I think that's, I like to think that that's true, right? So, I don't know, I struggle a lot of times with motivation to get a lot of the things done that I need to get done, and things that I want to get done too. And tomorrow is always kind of unclear if you don't accomplish the things that you have to do today. Tomorrow is not a certainty always, so it's always good to try to accomplish what you can while you have the chance to do so. Like I said, you guys made it halfway through the week, so that's a step in the right direction, right? And like I said earlier, if it's been a tough one, strong drinks may be in order. So cheers to you guys. I want to thank you guys for tuning in again this week. Obviously the episode run times kind of vary, but I'm glad that you guys all tune in. The last 2 episodes I did, both on Starship, essentially. We're the highest viewed that I've ever had on this channel. So thank you to all of you guys who took the time to listen and to comment and all sorts of stuff like that. I do appreciate it. Again, if you haven't done so yet, please go on over to the YouTube channel and subscribe to the channel. You can find me again on all sorts of other social medias, TikTok, Instagram, Facebook. Go and look at all the content that I have over there. And I look forward to talking to you guys later in the week and maybe next week, or obviously next week as well on Wednesday. So until next time, guys, I bid you to do more than just exist and come with me into the Introverse. Thank you guys. Appreciate you.